This is the first section of Chapter 3. We're talking about set theory. Set theory serves as a basis for much of mathematics. This is a study of collections, of groups, not in the same way as in algebra where you have groups, rings, and fields, but in collections. There's going to be some undefined terms as we talk about set theory, kind of like in geometry when you talk about points and lines and planes and stuff like that. But in this case, in talking about sets, there's just going to be some intuition. But one of the things that I think might be helpful to think about, it's been helpful for me, but one of the things to think about when you talk about a set is, I think it makes sense to talk about a set as a cardboard box. When we talk about sets, we're talking about a collection of objects. So in the same way that, you put a bunch of junk in a box, it's the box that holds all those things, and you could put a label on the outside of the box. I mean, you could put an A on the outside of the box, and that would be box A. In set theory, we talk about sets, and those sets contain members or elements. And the things that are inside of the set are very well defined, so that there's not an argument, or it's not based on opinion what's inside of the sets. If you recall back in chapter 2, we were talking about logic. We talked about statements, primitive statements. Those statements were facts. They were always either true or false, and there was no argument. There wasn't a debate. When we talk about sets, those also have to be well defined. And if we have a set, and we typically use capital letters to represent the set itself, we use brackets to represent the set, and then we list the elements or the members of the set within those brackets. And so we would say, for example, if the set A contained the members or contained the elements A, B, and C, we would say that A is an element of the set A. Or we would say J is not an element of the set A. Now there's actually 3 different ways that you can describe a set, and those are to either, I guess I'm going to be a little redundant here, but the first way is to list the elements, and the second way is to just describe it, or you could actually write out a description, I guess we'll say that. And then the third way that we have for describing the elements of the set is what's called set builder notation. And this is going to bring in some algebra so that we don't have to list all the elements. I want you to think about this one. If we said A is the set of the triplet A, B, and C, such that A squared plus B squared equals C squared, and A squared equals B plus C, and B plus 1 equals C. We need to make sure we understand that A, B, and C are elements of, what is that? Check out the end of this section. You'll see a table where it defines these reserved capital letters that represent the different sets of numbers. This is the natural numbers. I want you to think about what this set, that's a terrible bracket. I want you to think about what this set is. This set is made up of triplets such that, so this vertical bar sets up the rules that's going to describe these triplets, such that a squared plus b squared equals c squared. You probably recognize that. And then a squared is b plus c, and b plus 1 equals c, and then a, b, and c are all natural numbers. Okay? Let's check that out. That would be the set builder notation. This would be just the list notation. The list notation would be, well, let's see. What if we let's see, which is the smallest number here. What if we let b be equal to four. If b is 4, then c would be 5. Then a squared would be 4 plus 5. This would be 9. Okay. So a is 3. 3 squared plus 4 squared equals, what do we say c was? 5 squared. Yeah. This is a squared plus b squared equals c squared. 9 and 16 is 25. 9 is equal to 4 plus 5. And 4 plus 1 is 5. Okay? Let's think about what the next one would be. What if b is 12? Okay, b is 12. Then c is 13. And a squared is b plus c. b plus c is 25, so a is going to be 5. These are Pythagorean triples. You probably figured that out, but these are very special Pythagorean triples. They have these additional rules that apply. The next one is going to be 24 and 25. And then you add that together, you get 49. The square root of 49 is 7. So anyway, there you go. And then if we wanted to do this in the, write out the description, we would say A is the set, and you can just listen to me, I think. A is the set of Pythagorean triples such that a squared plus b squared equals c squared, but also the shortest side squared is equal to the sum of the other leg and the hypotenuse, and the hypotenuse is always just one more than the longest leg. Now, that takes a lot of words to say that. So you can see that set builder notation or the list method are certainly more efficient. But done well and done correctly, the set builder notation spells everything out, and then from that you can create your list.